This stoichiometry problem is going to have three different parts. To solve a stoichiometry problem, first you need to start with a balanced chemical equation. And right here we have a balanced chemical equation. Remember that a fundamental part of a stoichiometry problem is the ratios that you can determine using the coefficients from the balanced chemical equation. In fact, I have a little plan that I like to think of, and I'm going to cram it at the top of the page. But the path or the map that I like to use for stoichiometry problems, you're either going to be given the grams of a substance, or you're going to be given the moles of a substance. Okay? And you're going to be asked to find either the moles of a substance or the grams of that same substance. But A is what you're given in the equation, and then B is a different substance that's in that chemical equation. And you're either going to be asked to find that in moles or find that in grams. So then the plan would be we use to go from moles of one substance in a chemical reaction to moles of another, we use the ratio that we get from the balanced chemical equation. Now, that has to be in moles to use the ratio. The coefficients only can set up in moles. So if you're given grams, you have to use the molar mass of that substance. I don't know if I can write the word molar mass. It's too tiny. Told you I was going to cram it. Molar mass to get from grams to moles. And as well, on the other side, once you find moles to get grams, here you're also going to need the molar mass. So that's kind of a plan. If you're going to go from grams of one substance in the reaction to grams of another reaction component, you're going to have 3 steps. But you can have as few as 1 step. If you had 1 step, it would be going from moles to moles. So let's read the problem that I have here set up. It says 35 grams of aluminum hydroxide, that's one of the reactants, reacts with 35 grams of sulfuric acid, another reactant. And what they want to know is how many moles of aluminum sulfate. So in both cases, they've given me grams right here, and they're asking me to find moles over here. So I see that it's going to take 2 steps. I'm going to have to use the molar mass first. Then once I have moles of my substance, I'm going to have to go and use the ratio to get to my answer. So I'm going to have 2 steps. Now this is a limiting reactant problem, and you might say, well, how do I know? Well, in this case, they gave me amounts of both reactants. If they just give you one reactant, you consume the second or however many reactants there are in excess, and you don't have to think about them. But when they give you both reactants, you have to be able to use both reactants. And in some way, which I'll show you how I'm going to do it, you have to be able to compare how much of the aluminum sulfate both of them are going to make. So I set up 2 different problems. First, I start with the first reactant, the 35 grams of aluminum hydroxide. And remember, I'm going to have 2 steps. I have grams, so the first one is to convert it to moles. And before I wrote this, when I wrote it, I wrote the molar masses just to save time. So it's 78 grams per mole for aluminum hydroxide. So that's the first step. Now I would have moles of aluminum. This is aluminum hydroxide here on this step. And then to get the second step, I would multiply by the ratio. And the ratio for aluminum here, that is a 1, and the aluminum hydroxide is a 2. So let me rewrite that 2 so I can see it. So I put what I was given always goes on the bottom because it's going to cancel. And then the substance I'm looking for, its moles are going to go on the top. So I'm writing right now the ratio. I didn't need the molar mass of aluminum sulfate because they didn't ask for it in grams. So now plugging into my calculator, so just give me a minute. So So 35, I'm dividing that by 78, and then dividing that by 2. And I get 0.224, and I'll write underneath it just because I don't have a big space, moles of aluminum sulfate. So I'm cramming it. Okay. So that's how many moles 35 grams of aluminum hydroxide will make. Well, I have to compare both reactants. So now I'm going to do the same thing, but this time I'm going to start with the second reactant. They gave me 35 grams of sulfuric acid, and I'm going to convert it to moles using the molar mass of sulfuric acid, which is 98.08 grams per mole. This is the H2SO4. And then I'm going to multiply by the ratio. In this case, I have, let's see, it's still 1, but this case is 3. So let's do it. That would be 3. You always put what's given on the bottom, so it cancels. And then the 1 mole of aluminum sulfate on the top. And then let's do this, 35 divided by 98.08 divided by 3. And I get 0.11, it's 895, so I'm going to say 9 moles of aluminum sulfate. Okay, so we have 2 answers. So the question says how many moles of aluminum sulfate are produced. So when you have the 2 answers, what you're always going to pick is the smaller of the 2 numbers. Okay, because the smaller, what happens is when sulfuric acid makes 0.119 moles, then it's all used up and the reaction stops. This number right here really doesn't mean anything to us right now. Okay, the only reason I did that is to be able to compare the 2 answers. So I'm going to make the answer here would be 1.99 moles of aluminum sulfate. Now, we can name the 2 reactants that are there. Okay, the one that makes the smaller amount, the H2SO4, is called the limiting reactant. And then the one that makes the more, the one that is left over, this one will be left over because it could make more, and we know that because it got a higher number. This is called the excess reactant. Let's take a look at letter B. This question used the same balanced chemical equation, but it says 45 grams of sulfuric acid and 25 grams of aluminum hydroxide are reacted, and how many grams of product are produced. So if you remember from the previous page, when we know, so we're given grams of a substance A. First we have to use the molar mass, I'll just put MW actually for molecular weight, to change it into moles of A. And then with the second step we have to use the ratio from the balanced equation, and that will give us moles of B. Now in the previous problem A, we got to stop there after doing 2 steps because it only wanted moles. But here we need to go all the way to grams of B. I'll just put it there. So we have to use a molecular weight for B over here. So these problems, to go from grams to grams, we're going to have 2 problems again, and each problem is going to have 3 steps. Now again, I know this is a limiting reactant problem because they gave me 45 grams of sulfuric acid and 25 grams of aluminum hydroxide, both reactants, and you see here they want grams of aluminum sulfate. So I have to start with both, well, one way to solve it. And again, let me mention there's different ways to get to this answer. My approach simply is to take both reactants, solve to see how much of the product those reactants are going to make, and then I'll choose the one that's the lowest. So let me start. So I'll say 45, the first one. I'm 45 grams of sulfuric acid. This is what they gave me. I'm going to multiply it by the molecular weight or the molar mass, which is given. I calculated it before we did this problem. And then I'm going to multiply by the ratio. It's a similar process. Since I was given sulfuric acid, it is going to have the 3 on the bottom. And just recalling here, I'm getting the 3 from here. And then I'm looking for aluminum sulfate, so I'll look here. Since there's no number, that means 1. And then finally, now on the previous problem, letter A, I got to stop here because I just wanted moles right here, moles of aluminum sulfate. But I need to go to grams, so I'm going to multiply by the molar mass of aluminum sulfate, which is up there. This is for aluminum sulfate. Sorry, I'm cramming it in there. And this is going to be the answer. And what I'm answering is, if I start with 45 grams of sulfuric acid, how many grams of the product aluminum sulfate will I make? And as long as I didn't make any entering into my calculator wrong, I get to 3 significant figures, I get 52.3 grams of aluminum sulfate. Okay, and so that's how much I make with sulfuric acid. And now I need to check, well, how much if I have 25 grams of aluminum hydroxide, the other reactant. So I'm going to divide by the molar mass of aluminum hydroxide in order to change to moles of aluminum hydroxide. And I do that because I have to have moles to multiply by the ratio. Now in this example, I'm going to have, let's see, 2 is the number for the aluminum hydroxide, and then again 1, because in both cases I'm looking for the aluminum sulfate. I put aluminum hydroxide on the bottom since it's what I was given on the ratio, and I put what I want to find on the top. Then I'll multiply by the molar mass. And I get, if I enter my calculator correctly, I get 58.8 grams of aluminum sulfate. Now, so how I have it set up, how I've set it up here, now I'm going to compare my two answers here, the 58.8 and the 52.3, and I'm going to go with the one that is the smallest. So this is how much I would predict. This number right here is not part of the answers. I just had to be able to compare both reactants in order to figure out which one was the limiting reactant. So then looking at that, the sulfuric acid, since it made the least down here, then this is the limiting reactant. So it's going to get used up first. Upon completion, the limiting reactant will go to 0. And then the aluminum hydroxide, which made 58.8, is the excess reactant. Okay, So that is how we figure out here which is the excess and which is the limiting. Now before I move on, I need to go back and erase this number because I double checked my math before I kept going. And now I've done it twice, and you might have done it on your calculator and realized I've done it twice, and this time I got 54.8 grams on this one. It's still lower, so it still keeps my answer the same. But I did it twice, and I just double checked my math because once I leave this page, I can't go back and fix it. So anyway, it still is the same because the 54.8 is larger. It means the 52.3 is the how much we would make. Okay, so we have one more question with this problem. It involves the same chemical reaction. And this time, let's read it carefully. It says you have 2.5 moles of aluminum hydroxide. It reacts with 5.5 moles of sulfuric acid. Which substances will be present at the completion of the reaction, and how many moles of each? Okay, so think about it. Aluminum hydroxide and sulfuric acid are the reactants. And they're going to make two products. They're going to make aluminum sulfate right here and water. So we know at the end of the reaction, those two products are going to be made. One of the reactants will be gone, the limiting reactant, so it will be 0. And then there'll be an excess reactant. So let's think about it. Now, before I go any further, they gave me moles and asked me to find moles, which means the only step I'll have to do is multiply by the ratio. So the first thing I'm going to do is I'm going to figure out which is the limiting reactant. So I'm going to start with the 2.5 moles of aluminum hydroxide. And I'm going to see how much aluminum sulfate is made. So looking up here, there's a 1 and then a 2 there. It's a 2. And so then I'm going to put the 2 moles aluminum hydroxide and the 1 mole aluminum sulfate. Okay, so that is 2.5 divided by 2. Okay, so 1.25 moles of aluminum sulfate. That's how much the 2.5 moles of aluminum hydroxide will make. And then I'm going to figure out, okay, I also have 5.5 moles of the sulfuric acid. And for the sulfuric acid, if we look up here, we have a 3 and a 1. So I'm going to put the 3 moles H2SO4 on the bottom and the 1 mole of aluminum sulfate on the top. And I get 5.5 divided by 3. And I get 1.83 moles of aluminum sulfate. Okay, so what I know is, I can get quite a bit of information from what I just did. What I know is that aluminum hydroxide is the limiting reactant. And I know that because when I compare the two answers, how much each one of them will make, I see that the aluminum hydroxide will make a smaller amount. It will make 1.25 moles of the aluminum sulfate. Okay, so I know that the aluminum hydroxide is going to go to 0, and the aluminum sulfate is going to be 1.25. That also means that the sulfuric acid is the excess reactant, which means there is going to be some of the excess reactant left over. We're going to have to calculate it. This number right here means nothing to us. Remember, the only reason I calculated that was to compare to the what the aluminum hydroxide made. Okay, so remember 1.25 moles of aluminum sulfate. Okay, so what I know so far is 1.25 moles of aluminum sulfate is going to be made. Okay, I also want to know, I knew that the H2SO4 is the excess reactant. Now let me take a minute. I want to see if I can copy. I'm going to try something. I'm going to copy the equation over here so we can look at it. Okay, so what we know now, I can erase this. We know how much aluminum sulfate is going to be made. So now I need to know, well, how much water is going to be made? How much of the water will be there? Okay, I already determined that the aluminum hydroxide was the limiting reactant. And how much? I had 2.5 moles of that. So to calculate the water, I can take the limiting reactant, because I know it's going to be limiting for the whole reaction. Whoops, that's moles. And figure out how much water is going to be made. So that's 6 moles of water for every 2 moles of aluminum hydroxide. Okay, so 2.5 times 6 divided by 3, times 3. 2.5 times 3 equals. Sorry, I made it wrong. 7.5. Okay, 7.5 moles of water. So now I have 2 of the answers that I needed. So, because if we think about the problem said if you have 2.5 moles of aluminum hydroxide and 5.5 moles of sulfuric acid, how much, after the reaction's complete, how much do you have of each one? So I know that I have 1.25 moles of the first product, aluminum sulfate, and I know that it will make with aluminum hydroxide, the limiting reactant, I will have 7.5 moles of water. So these are the 2 products, and that's how much I would make. Now there's one more thing. Remember, we have up here that sulfuric acid is in excess. So I have to figure out how much sulfuric acid is going to be present. Now it's not a simple, you have to do one more calculation. You can't just subtract at this point. So we know that I started with 5.5 moles of sulfuric acid, but I have to figure out how much I'm going to use. Now there's different ways to figure out, we figured out this, and we figured out this. There's different ways to figure out how much is used, but this is what I do. I start with the limiting reactant. So we have 2.5 moles of aluminum hydroxide. This is the limiting reactant, and I'm starting with it on purpose because I know what I'm trying to ask myself is not a question that they ask me directly, but that I need to know, well, how much of the sulfuric acid will react with my limiting reactant. So let's see, there's 3, looking at the ratios above, 3 moles of sulfuric acid to 2 moles of aluminum hydroxide. And this is how much, so 2.5 times 3 divided by 2 is 3.75 moles of sulfuric acid. Or I guess to 3.8 moles of H2SO4 is used. This is how much right here reacts. Well, they want to know how much is left over. So now I take from the beginning of the problem, they said that we had 5.5 moles of sulfuric acid to begin with. So this is what we started with from the beginning of the problem. We subtract 3.8 moles, which is what was used with the limiting reactant, because remember it was a reaction, minus 3.8, and I get 1.7 moles of sulfuric acid. So this is our third and final answer. So we figured out on the previous page how much aluminum hydroxide was made. We figured out how much, well, let's see if I can look back. Right here, we figured out that 1.25 moles of aluminum sulfate was made. 7.5 moles of H2O was made. And then we figured out that 1.7 moles of sulfuric acid, this is how much remains. And so now we've solved all three of our problems for this particular question.